To do this for Mo, I'm recording. So the main definition of a logarithm, the log base b of x equals y. So if I have a logarithm, what I want you to realize is that logarithms are simply exponents. They're just a fancy way of writing an exponent. Specifically, log base b of x says what is the exponent on b that would give me x. And so logarithms and exponents go hand in hand, okay? A logarithm is just an exponent. It's the exponent on the base to yield the number that's inside that logarithm. So I always, when I see a logarithm, I immediately in my head turn it into this problem, b to the y equals x. So I would say to myself, log base 7 of 49 asks me what is the exponent or the power on 7 that gives me 49. Log base 5 of 1/5 says 5 to what power is 1/5. I don't have to put the parentheses anymore. The next one, 3 to what power gives me the 4th root of 3. If there's no base down here, what's that understood to be? Megan, do you remember? If there's no base down there?
Well, I know the answer.
You know the answer. What is the base understood to be? 10. So right, 10, because 10 to the 4th, did you get 4 on that one? Yeah. So the base down there is considered to be 10 if you for that one. Yep, beautiful. And then ln is a base of what? E. So when you see ln, that's understood. Ln, the natural log, is written as log base e, and log is log base 10. And those are the two most commonly used logarithms, which is why they appear on scientific calculators. Log base e, because e is that natural number that occurs in nature all the time, and then 10, because 10 is our decimal system, what we're based on. Alrighty, good. So here we go, starting with A. Abel, did you get the first answer A? What should that be? 2. 7 to the second power gives us 49. Megan, did you get the next one by any chance? -1, because 5 to the -1 is 1/5. Beautiful. Did anybody get the third one? Blake. 1/4, absolutely. Because 3 with the fourth root of 3 is 3 to the 1/4. And so what you're really doing is taking 3 to the 1/4 gives me 3 to the 1/4. Absolutely. And Ella, did you get this one, log of 10,000? 4, because 10 to the 4th is 10,000. And how about that last one, that one, Mason? What do you think? That's right, that one's 4. The question mark has to be 4. E to what gives me e to the 4? That has to be 4. Beautiful, you guys are all good with those logarithms. Now, sometimes you can't find that logarithm easily. For instance, log of 27 says 10 to what power gives us 27. And those you can't figure out in your head, in which case that's when you use a calculator. Evan, did you get a calculator value for that? What did you get for the log of...
The whole thing or just...
Give me to the nearest 3 decimals.
Okay, 1.431.
1.431. Do you guys all agree? Beautiful, beautiful. And Katya, did you get the natural log of 173?
5.153.
Oh, say again for me.
5.153.
5.153. Beautiful. Guys good? Everybody's good so far? Okay, so how about this one here? This one simply says rewrite as an exponential equation. Declan, did you do that one? Can you rewrite that for me as an exponential equation? Uh-huh. Beautiful. That is the exponential equation that corresponds to that logarithmic equation. Shane, you want to help me out with the did you rewrite this guy as a logarithm? Go ahead. Beautiful. That's exactly right. That's exactly right. How are you guys? Are you guys like 5 for 6? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 for 9?
Solve the one.
Close. Good, 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 good. So now we move on to for our warm-up here. Here we go. Log base 4 of 2x plus 3 is 2. So first thing is I take every logarithm equation and I rewrite it as an exponential equation. So I would say 4 to the 2 equals 2x plus 3. And then I would solve. Ella, did you solve that down?
Yeah,
X equals 13. You know what? I'm going to go ahead and just solve this really fast to make sure I get what you get. So you said 13 equals 2x, and so then you said 13 over 2 is x. So you said x is 13 halves. Guys all got 13 halves? The next one, 6 to the x is 216.
3.
Oh, 6 cubed is 216? Is that true? Oh, nice. That last one, how about that last one? It's 2 to the 5x plus 1 equals 16. How did you solve it? Who solved this one? Blake, what did you do?
I did 16 equals 2 to the 4th.
It does.
And then I put those equal to each other. And then just put the exponents equal to each other. So
Beautiful. You got both the bases to be the same. So 16 is 2 to the 4th. When both of those bases are the same, then we can equate the exponents. So 5x plus 1 is 4, which means 5x is 3 because we subtract 1. And so that means x is 3/5. How are you guys with that warm-up sheet? How are we feeling? How are we feeling? Questions? Did that sufficiently warm up our brains? So what I want to do today, is I want my students to have these rules for logarithms and feel good about using rules for logarithms. Okay? Logarithms come up in calculus 1. They come up in calculus 2. They come up in calculus 3. They come up in every course mathematically after this. You will also see them in science courses. You will see them in, I guess, physics and engineering are considered science courses. So we want, especially because you guys are all taking calculus 1, we want to make sure we become logarithm experts, specifically experts at using the properties of logarithms. So we want to focus right now on 1, 2, 3, 4 properties of logarithms. I want to focus on 4 properties of logarithms. But before we focus on 4 properties of logarithms,